Okay, so what we are going to go over today is pretty much just a lot of algebraic connections with geo, a little bit of recap with writing equations of lines. So when you're thinking about slope-intercept, that general equation of a line form, it's y equals mx plus b, where m is your slope, and then b is that y-intercept, where it crosses the y-axis. Things that we need to remember about our horizontal line, right? Remember HOI, that the slope of this is 0, and the slope of our vertical line, our box line, is undefined. If m is positive, that means the slope is positive, the graph is increasing, which means when you're reading it from left to right, from left to right, it's going up. If m is negative, reading that graph from left to right, it's going down, it's decreasing. Other formulas that will be super helpful to know is, yes, the slope formula, which we have kind of recapped in the last unit, y2 minus y1 over x2 minus x1. Our midpoint formula, which is x1 plus x2 all over 2, and then y1 plus y2 all over 2. Our distance formula, which we talked about a little bit with the midline, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. And then, you simplify underneath that square root and then the square root of that simplified value. Okay, so let's practice graphing given this function. We're given x plus 2y is equal to 10. And we want to graph this equation in our graph on this right-hand side. Before I graph, I'm going to just go through each of these examples, which I think will help us to graph. It first is asking us to find the slope. So using this form, right, this is just standard form of a function, we need to get the y value by itself in order to find the slope, to put this in slope-intercept form. So let's start with our function and then work to isolate the y. So our first step in this case is to subtract x on both sides. So we get 2y is equal to negative x plus 10. And then divide each and every term by 2. So y is equal to negative 1/2 x plus 5. And in this case, because m, right, is just that value attached to x, that's going to be our slope. Our slope is negative 1/2. Our y-intercept is just that number that's added or subtracted onto the nx value. We want to write our y-intercept as 0, comma, a number. At this point, we can certainly use our slope and our y-intercept to graph this equation, and I think that it's kind of a great point to do that. So let's start with graphing that y-intercept to start. So with that y-intercept of 0, 5, we'll start at our origin, go left, right, nothing, but go up 5. 1, 2, 3, 4, 5. And that'll be the point that function crosses the y-axis. Let's use our slope from that y-intercept, right? The top tells us up, down. The bottom tells us left, right. So I'm going to use the negative and make the top negative. So it's going to be down 1, and then to the right, 1, 2. Down 1, right 2, down 1, right 2, down 1, right 2. And at that point, you get a good idea of what the general shape of this function is. And of course, using a straight edge, we can make sure that that line is nice and straight. Okay, let's go back and fill out the rest of this chart. and we're asked to find our x-intercept next. So I highly suggest just using this function, this x plus 2y equals 10. And because we know x is 0 when we're finding our y-intercept, we can just plug in y for 0, because then it's going to be an ordered pair, an x value comes 0. So let's plug in 0 for y, and then just solve as is. So 2 times 0 is 0, that drops away, and we get x is equal to 10. Cool. From there, we're testing to see if negative 4, 3 is on the line. So I think the best bet with this is to use this ordered pair x comma y and to plug in negative 4 into x into this function. So it will just be read as negative 4 plus 2 times 3 equals 10. If the left is equal to the right, then yes, right, that point satisfies that function. And when we simplify this, negative 4 plus 6, well, unfortunately, that does not equal 10. So no, that point is not on the line. And if you even looked at your sketch on the right-hand side, you'll see that that doesn't work. The line passes through quadrants, and this is kind of just a recap again from algebra. Line passing through our quadrants, we have 1, 2, 3, and 4. So the only quadrant that this graph does not hit is 3. So we can just list 1, we can list 2, and then we can list 4, which is ID, using those Roman numerals to name our quadrants. A line parallel has the slope of parallel. What we should be thinking about is same slope. So this parallel line will have a slope of negative 1/2. A line perpendicular, again, we should be thinking opposite reciprocal of this original function. So we negate it, make it the opposite, so minus a negative, so positive, and then flip top and bottom, which really just simplifies to 2. Okay. A line perpendicular with a y-intercept of negative 3 is described as by the equation. Again, just recapping our slope-intercept form, y equals mx plus b. We're talking about a line perpendicular, right, to the original function. So we're using that same slope that we determined in that part G. So y equals 2x, and then our y-intercept is given in this function of negative 3. So y equals 2x minus 3 is indeed that function. Okay. Something also to try by testing a point of an equation, whether it lies on that function. So our first example, kind of like above, is using negative 3 as x and 0 as y, and then just determining if that point does lie on the circle and in this function. So if you plug in negative 3 for x, square it, and compare it to your y value, and square it, and then set it equal to 9, does that left-hand side equal the right-hand side? 9 plus 0, that simplifies to 9. 9 plus 9 is indeed true. So the point does lie on the circle.